the last page that we have. Now, do you all know, if I were to say, write 0.4 as a fraction, you would all say, I hope, 4/10, and then reduce that to 2/5. When decimals are what we call finite, when they stop, then it's easy. If it's 1 decimal place, it's over 10. If it's 2 decimal places, it's over 100, and so on, right? But what if they're repeating decimals? 0.4 repeating. Well, you can't do that. It doesn't work that way. You can't do it like you do regular decimals. This means 0.44444. Would you agree with that? Another way of thinking about that, and you don't have to write this down, but I want you to think about it, would be 0.4 plus 0.04 plus 0.004, and so on. Would you agree that if I added these up, that's what I would get? So what we have right here is an infinite geometric series. Our formula we talked about last time is this. What am I multiplying by to get from term to term here? What's happening? I'm multiplying by 0.1. Aren't we dividing by 10? Which is the same as multiplying by 1/10. So my ratio is 1/10. 1 decimal place, 1/10. 1 decimal place is repeating, so my ratio is 1/10. My formula says, take the first term, which is 0.4, and divide it by 1 minus the ratio. Well, what's 1 minus 1/10? 0.9. So we have 0.4 over 0.9, which is the same as 4/9. You're allowed to get rid of the same number of decimals places on the top and the bottom. So if you have 0.4 and 0.9, you can get rid of those points, and it's just 4/9. So the fraction for repeating 4s is 4/9. Now, I know we discussed this. Those of you that took summer math with me way back in the day, we talked about this. If you have repeating 5s, that's going to be 5/9. If you have repeating 6s, that's going to be 6/9, which is 2/3. Here is the math behind that. We didn't talk about this back then, but this is the math behind it. When you see a repeating decimal like 0.4, 0.1, 0.6, it's that number over 9 every time. Now when it gets a little harder is like the next problem. How many places are repeating in this decimal? Not just 1 place, but now we have 2. You can do it the same way. The difference is the ratio will be 0.01. Instead of 0.1, when there's 1 decimal place repeating, 1 decimal place, 0.1, 2 decimal places repeating, 0.01, 3 would be 0.001, and so on. So set up your formula. Your first term, the first chunk that repeats, is 0.63. Your ratio is 0.01. So here's your formula. Anytime you're infinite, and that's what this means, it repeats forever, it's infinite, you're going to use this formula. Your first term is the first chunk that repeats. So over here, our first term was the 0.4. Now it's the 0.63. What is 1 minus 0.01, 0.99. You're allowed to move the decimal point the same number of places. So this is just going to be 63 over 99, which reduces to what? Let's see, 3, actually, 9 goes into both of those, right? So 9 goes into their 7 and 11. Take your calculator and do 7 divided by 11. Just 7 divided by 11. What's it say? Does it say that? Now, C is harder yet. What's different about problem C? Well, we have a number thrown in there that doesn't repeat, right? It's not part of the repeating. So we got to think about this as kind of like two problems. We've got our 0.1 over here. I'm going to pull him off. And then we have, what is our actual first term? If we pull this out, our actual first term is 0.04. You have your 0.1, but then you have a 4 here in the hundredth spot, so it's 0.04 and 0.004 and so on to get the 4s. This is the only part you can use your formula for. This doesn't fit. This is different. He doesn't fit. So I'm going to use my formula for this, the formula I just erased. I'm going to use this formula. Okay? So what's my first term? .04. Now, be careful. What's my ratio? 0.1. Whoever said that, you're right. Why is the ratio 0.1? How many numbers repeat? How many numbers actually repeat? 1. And it's the number of numbers that actually repeat. So when 2 repeated, it was 0.01. But when one number repeats, it's 0.1. So now we have 0.04 over 1 minus 0.1. Well, what did you say 1 minus 0.1 was? 0.9. Now, don't just erase the decimal places. Remember, you got to move it the same number of spots on the top and the bottom. So if you want to get rid of this decimal, you're going to have to move it 2 places. Then this one's going to have to go 2, which means the number is going to be 4 over 90. Did you follow that?
Yeah.
So, I know that reduces, but wait a minute, because I'm not done. That, remember, is all of this. What do I still need to figure in? The original 0.1, the part of the decimal that didn't repeat. So I'm going to have 4 90ths plus 1/10. How do I add fractions? Common denominator, so I'll make that. So 90 is my denominator. What's in the numerator? 13. Just for fun, 13 divided by 90 on your calculator. I bet you get this. If you don't, we're in trouble. Right? All right, 2.3333. All right, let's talk about this. Get it sorted out. What's our strategy going to be?
Take away the 2.
Take away the 2. So I'm going to have 2 plus .3333333, right? Alright, so this is what I'm going to use my formula for. I use my formula for the part that's repeating. And then once I do that, I'll add back in the other part, like I did over here. But I got to do this part first. Okay? What's repeating here? Just the 3? So my numerator is 0.3. That's the first part of the repeating fraction. 1 minus, what's my ratio? How many places are repeating? So 0.1. So 0.3 over 0.9, which is 3/9, or 1/3. You probably knew that one already. Did you know 0.333 was 1/3? Probably did. But you're not done. What do you have to do now? You have to take that 1/3 and add in the 2. So you can either say 2 1/3, or you can say 7/3 if you'd rather write it as a fraction, involve a fraction. One more. 1.7. All right, tell me what's going through your head. So we got to remove the 1.7 because he's not part of the repeating pattern. And the formula is only going to work on the repeating pattern, right? All right, so now what? You're right, I have to pull that off, deal with him separately. Now what? Exactly, Ethan. My first term, what I'm going to use my formula for, my first term is 0.041. Because the first repeating thing is at 41, but I had to pull the 7 off, so there's a 0 in front of it. There's the decimal point, so it's 0.041. That's my first term. And what's my ratio? 0.01. Because in this number, how many places repeat? 2. When 2 places repeat, it's 0.01 for your ratio. So 0.041 over, what did you say 1 minus 0.01 was? 0.99. Now we got to move the decimals, get rid of the decimals. So this top is going to have to move 3 places. And so is the bottom. So what am I going to have? 41 over 990. I don't think that reduces. So there it is, 41 over 990. What's left to do? Add in the 1.7. So 1.7, I'm going to say 17/10. Does that make sense to you? That 1.7 would be 1 7/10, or 17 over 10? Olivia? 1 decimal place is tenths, always, right? So this is 1 7/10.
So we would like to replace it with like 17 over 10.
Yep. Yep. What do I do to add these two together? Common denominators. So let's see. I guess I'll multiply this one by 99. So I don't know, what's 99, oh, I gave away my calculator, what's 99 times 17? 1,683. And then I gotta add 41 to that. So what is that? 1724? Over 990?
Yeah. What did you say that?
I multiplied these two, I didn't get the common denominator, so I multiplied these two, I got 1683. But then I have to add it to the 41. That is divisible by 2. 862 over 495. I think that might be it.
Is that what it reduces it?
Yeah. Alright, type it in on the calculator, let's check it. What's 862 divided by 495? 862.
1.74.
There you go, so we did it. We did it. Alright, well, we'll have some of that in our practice also. But that's the last thing. Alright, so 9-5 homework will be due on, let's say, Wednesday?
Yeah.
I guess it's due Friday. 9-5 homework's due Friday. I thought today was Thursday. Oh boy. Today is Thursday.
No, today.
Okay, let's do Monday. I was right first time. Yeah, let's do Monday. Thank you.
Right there, Jesus.
My days are all messed up.
I thought it was Wednesday too.
I know. I can't
No,
keep
is
that
it?
straight.
No.
In my mind, day 3 should be Wednesday, so when it's off.
Are we gonna have a test on this unit?
We are gonna have a quest. It won't be a test, it'll be a quest. We're gonna review right now, and then we'll do that. So, certainly it won't, I don't know. It won't be the next class. I know that for a fact. Probably won't be the next one after that, or probably the next one after that, but we'll know more after we get going here on the review, okay? Everybody got it? All right, let's get our review out that I just gave you, and let's get started. I have this posted in school. Did you get a tweet? I put it in there, and there are some answers also included. I just handed them out. You want to hear when I hand them out? All right. Here we go. Number 1. Is it arithmetic or geometric or neither? Give the common ratio or the common difference if applicable. So let's look at problem number A. What do you think?
+3, +4, +5, +6.
Okay, so Gabe has found the pattern. Is that, he's got a pattern, but is that pattern arithmetic or geometric? No, because to be arithmetic, you can't add different numbers. You have to add the same number over and over again. So this is a neither. Neither, move on. How about B? +3, so it's arithmetic, and the common difference, you can just say D equals 3. It's arithmetic, the common difference is 3. All right, C.
-7.
You're multiplying by -7, which makes it geometric, and the ratio is -7. You can just write R equals -7. D. Arithmetic, its common difference is -2. We're going down by 2's. And E. Geometric, the ratio is 1/2. Aren't we multiplying by 1/2? Remember, when we do these sequences, we have to think about what we are adding or what we are multiplying. So don't say dividing by 2. That's what's happening, but that isn't the ratio. The ratio is multiplying by 1/2. Okay? All right. I didn't write the formulas down on the paper here, but I will have them written for you. So I'll just list them up here at the top of the board. You've got them in your notes. Using our formulas, and we have 5 of them, we need to figure out the answer to this next question. So here are our 5 formulas. Those are going to be handed to you. You just need to know which one to use. So let's look at number 2. Find a sub 16. Well, you have a clue. It's one of your A formulas, isn't it?
Yeah.
So now you got to decide what's happening in the problem.
Plus 4. No, 6.
Plus 6? So if it's plus 6, it's arithmetic. And if it's arithmetic, which of these 2 is it?
The second one.
The second one, it's this one. So the 6, I'm going to use that formula right there. So the 16th term, that'll be a sub 16, is the first term, -2, plus the common difference. What did you say? Add 6. And then what's going to go in the parentheses?
16 minus 15.
16 minus 1, or 15.
Yeah.
So we multiply first, always multiply first. So that's 90. So 88. You get 88 as the answer?
Yeah.
All right, number 3 says find S sub 12. So clearly we're going to use one of our S sub formulas. So it's either that one or that one. It's not this one because this doesn't have a sub on it, right? So it's either this one right here or it's this one right here. Does that make sense to everyone? So now you're going to decide which one is it. Let's look at our sequence. What's happening?
Multiplying by 2.
Multiplying by 2, which means it's geometric, which means it has a ratio, right?
Yeah.
Is that guy right there? So here we go. S sub 12, you gotta take care of?
Yeah.
Good. S sub 12 equals the first term, which is 3, minus 3 times the ratio to the 12 over 1 minus the ratio. Look at what I wrote. Does that make sense to you? Can you write that by yourself, plugging the numbers in? Okay? Now, remember my hint is, I think it's always easier to go ahead and do this, so I'm going to make that a -1. When you type in the numerator, make sure you hit equals before you hit divided by. All right? So I'm going to type this in and see what I get. 3 minus 3 times 2 to the 12 divided by -1. Did you get 12,285?
Yeah.
Yes.
That's great, because yesterday when we were doing this, we weren't all getting the right answers, so that's good. That's good. Anybody have any question about that? Now, number 4 says find S. Now notice it doesn't have a sub on it. So isn't it that guy right there?
Oh.
So all I need to know is the first term, which is 30, and then the common ratio. What am I multiplying by? 1/2. If you want to type this in right now, you can, but this has got to be in parentheses. I like to say 30 divided by 1 minus 1/2 is 1/2. right, or 0.5. So 30 divided by 0.5 is 60. Make sure you get 60. As long as you're getting 60, it's all good. I don't care what you're doing. 60 is it. So far, so good? Yeah, so far, we haven't hit anything too tricky. All right, let's look at part 5. Limits. Raise your hand if you have an answer for A in the limit problem. I see a couple of hands up. A couple more up. All right, Roxy, what do you think A is? What? No, it's not 0. But what do you think, Olivia?
I think it's -2/4.
Or -1/2? Right? So she's exactly right, it's -1/2. Now, why is it -1/2? Well, when you have n's over n's, you compare them, right? You make a fraction out of them. So what do I have on top? 2 n's, and on the bottom I have -4 n's. So that's how she got 2 over -4. Everybody get it? With me? That's what we reduce it then to get the 1/2. All right, let's try B. Raise your hand if you think you have an answer to B. Got a couple hands up. There's another one, another one. All right, Kennedy, what do you think B is?
5/7.
5/7. It's exactly the same as problem A, only the big power is the square. So it's 5 squared over 7 squared.
What about the 6 then?
Doesn't matter.
Doesn't matter?
Remember, the only thing that matters is the biggest power. Ignore everything else. Okay? All right, C is a little different. Raise your hand if you have an idea what the answer to C is. Got a couple hands up. Is that all? Oh my goodness.
Wait, which one are we on?
C.
C?
Avery, what do you think C is? 0. Why is C 0? Because the number in the parentheses, the number we're raising to the power, is less than 1. And when it's less than 1, the limit is 0. All right, D is a little harder. Anybody have a thought? Who said 0? All right, Gabe, you're the limit master. Why do you think it's 0?
Because the square's on the bottom, so you gotta put 0 and squared on the top.
Exactly. I could not have said it better myself. He said it perfectly. He said, look, the biggest power is n squared. I don't have any on the top, so I'm going to put a 0 up there. And that leaves me with 0 divided by 6, which is 0. So the answer to D is also 0. C is 0 and D is 0. All right, what about E? Divergent, no limit. Because why? The number in the parentheses being raised to the power is more than 1. And when that happens, there's no limit, it's divergent. I did not take attendance yet. Who am I missing? Tatiana and who else?
And Foster.
And Foster. Is Foster doing okay? What's going on with Foster?
Yeah, she's just sick.
All right, I'm missing Diana. Foster. All right. Last limit problem. What do you think about F? Divergent. Why?
Because it would be 2 over 0.
Exactly. It's the same reason we were talking about over here. The highest power in F is squared. So we have 2 squares over no squares. Hey guys, not doing it today, okay? Our last class was really hard on me because there was a lot of disrespect happening. We're not doing it today, okay? So Michael, turn. All right, number 6, here we go. Find the sum of the first 20 terms. Find the sum of the first 20 terms. That notation alone clues you in that it's either this one or this one. Does everybody see that? So now we gotta figure out which one it is by figuring out what's happening in the problem. All right, so what's happening?
Plus 4.
We're adding 4, which makes it arithmetic, right? Which is which one of these? Second one. This is arithmetic, right? This is arithmetic. So the sum of 20, according to the formula, will be 20 over 2, n, 20 over 2. What's my first term? Negative 18. Oh no! What do I need here? The final term, the last term. Do I know it? No. What do I do when I'm trying to use a formula, but I don't have a number that I need? I go back to the other formulas. Remember, we did this last time. We go back to the other formula. So the other formula is right here. I need a sub 20. That's what I need to find. So this formula right here says a sub 20 equals the first term, which is negative 18, plus the common difference, which you told me is 4, times n minus 1. And if n is 20, this will be 19. So I can figure that out. 4 times 19 minus 18, I got 58. Remember, if you're trying to use a formula and you discover that you're missing something, jump over to the other formula, and then once you get that, can I now plug that in right here? So I have 10, 20 over 2, 20 over 2, 10, times negative 18 plus 58. Plugging this in right here. So I think that's 400, but you double check me. So the answer to the problem is 400. A sub 8. Doesn't it narrow down which formulas? I mean, don't you just have 2 formulas that could possibly work on this problem? This one or this one? Those are the A formulas. I'm not going to switch the letters up on you. The letters are clues. All right, which one am I using? What's happening in this sequence? Timesing by negative 2. So that means it's geometric, which means it's this one. So the 8th term, using that formula right there, would be the first term, which is 12, times the common ratio. What did you say that was? -2. Multiplying by -2. And what's my exponent going to be? Be careful. What's my exponent? 7. Because n is 8.
And you get negative 1,538.
Oh, you got it already? Good deal.
Just kidding. I could be wrong.
You could be wrong.
Or I got it right. Or
What did you say you got?
Negative 1,538.
I got 36.
Yeah, that's why I said I think I'm wrong because Kai's right.
I don't understand how you could,
Me neither, because I just typed that in. I probably did that one thing where I don't do the equals first.
you don't need to run this one, so type 12, parentheses, -2, close parentheses, raised to the 7th. Did you
You got
get
it right this time.
Okay.
No, I didn't.
1,536 negative, negative 1,536. All right, we only got a couple more on this sheet. Write an explicit rule for this sequence. What in the world am I talking about? An explicit rule is just a formula. Just a formula. Here's my sequence. What's happening? Adding 3. So my difference is 3. It's arithmetic. Difference is 3. This is your arithmetic formula. So A sub n equals the first term, which is 10, plus the common difference, which you said was 3, times n minus 1. Remember, we're not coming up with a number this time, we're writing a formula. So our formula, if I clean it up by doing the distributive property, our formula is 3n plus 7. Here it is. That's your formula. So how did we do that? It wasn't hard. We figured out it was arithmetic. That's, you have to do that. You have to figure out what kind of sequence you have. We figured out it's arithmetic. This is my arithmetic formula. I plugged in the first term, and I plugged in the common difference. And then the rest of it is just distributing and collecting like terms. Easy as pie. That's your explicit rule or your formula. What's happening here? It's geometric. We're timesing by 4. So my ratio is 4. So what formula will I use if I need to write a formula for this problem? That guy right there. So the nth term is the first term times the ratio to the n minus first. No simplification with that formula. Do not multiply the 3 and the 4. We talked about that early in the year. Order of operations, exponents come first. You cannot multiply these. This is your formula. How did we get that? We plugged in our first term, and we plugged in our ratio. That's all we had to do. And then finally, we have our last problem, which is the last thing we just talked about. Our decimal, is that line over both numbers? Yes. So it's 0.34. Avery?
No, you're gonna take an important call behind.
Okay. That'll be important. Better not be a friend wondering what to order tonight or something. Okay.
Hold on, Thursday.
All right, 0.34. 0.34. All right, let's stop and think. We really haven't had much practice with this, just a few problems today. We know the formula we're going to use is this one. this is the infinite formula, that's an infinite decimal. So we know that, that's the formula we're gonna use. Can you tell me anything about my a sub 1 or my r? Either one. R is 0.01. How do we know that R is 0.01? What's the key? 2 repeating places. If there's only one repeating number, it's 0.1, but when there's 2, it's 0.01. All right, so we got that. What's our first term going to be? Think about writing this decimal out. If you wrote it out, wouldn't it look like this? The first term is the first repeating chunk. So the first repeating chunk is just 0.34, isn't it? This is not one of those hard ones that has like an extra number second or something. It's just 0.34. So now, what's 1 minus 0.01? 0.99. So now we have 34 over 99, because we're allowed to move that decimal point 2 places. If 34, is everything okay?
Yeah.
If 34 over 99 reduces, I need to reduce it. Does it reduce?
No. Yes.
30? I don't think it does. Because this is 2 times 17 and 2 doesn't go into 99. So I think that's it. Check it on your calculator. What's 34 divided by 99? Is it 0.34 repeating? That's your check. If you divide that, you better get what we started with, or we made a mistake. Okay? All right, we're gonna do one more section here. I'm gonna hand back some papers I've got. But let's look at PreQuiz 9495, the next page. And I need to add to the directions so it matches the test. Identify the sequence as arithmetic, geometric, or neither. Give the common ratio or the common difference. So if it's geometric, you need to tell me what R is. If it's arithmetic, you need to tell me what D is. So take a second, see if you can figure those out, and then we'll talk about them, and then I will be done. Oop, not that class.
Yeah.
If it's an emergency, go ahead and go. But you guys,
I only focus on one side.
figuring out if they're arithmetic or geometric, and then you're going to tell me the ratio or the difference. I'm not sure. I'm just not sure. What?
You said go, right?
If you have to go, I mean, if it's an emergency, go. You don't look like you're in an emergency mode, though. All right, let's talk about these and see what you ended up with. A, what did you decide? Is it arithmetic or geometric? Problem A. Arithmetic. So its difference is 1. Aren't we adding 1? Now that's all you had to do on this problem. So we didn't really need a formula or anything. You're just looking at it and deciding what's going on. All right, what about B? Geometric. And you're multiplying by 2/3. You have to be able to figure that out. Can everybody see that's what we're multiplying by? That's our ratio. Okay, what about C?
Neither.
C is a neither, because even though you can probably see a pattern, You're not adding the same thing or multiplying by the same thing, right? All right, we'll stop there. Remember, you've got homework due on Monday. And we'll be having a quest. Not next time, maybe the time after that.